session. So this is about a Flash Type ADC. So it is a topic from Unit 4. ADC consisting of 4 types. So one is Flash Type, another one is successive approximation, and next one is slope detectors. That is single slope ADC and dual slope ADC. So this Flash Type ADC is basically a fastest ADC. Then the construction wise, it has 8 comparator and 8 resistance values and then 1 encoder. We applied the analog input and the reference input to this comparator circuit. The comparator will compare that particular value and given to this encoder circuit. After the processing, encoder will convert this analog wave into a digital formation. Okay. So in this construction, we have to consider this resistance value, but this resistance value will be written as VR by 8. After that, 2 VR by 8 and 3 VR by 8, 4 VR by 8, 5 VR by 8, 6 VR by 8 and then 7 VR by 8. So this value is written by the formula. The formula is about a corresponding voltage, that is our VR. The corresponding voltage is VR. So VR into corresponding resistance, that is our R, right? So R divided by total resistance in the circuit, that is 8 VR, right? So have to cancel this value as, so this VR here will be cancelled. So we have to write that VR by 8 in that portion. Okay. So next one is after that 2 VR by 8. Same procedure, same the corresponding voltage into corresponding resistance divided by sum of the resistance in the circuit. Okay. That's why I write this formula. Okay. Then the comparator. So comparator basically having 2 input terminals. One is inverting and one is non-inverting. So whenever I am applying a signal to this comparator, it will compare that value. If it is I will apply a 1 to the inverting terminal and 2 to the non-inverting terminal. So the value of 2 is higher than 1. So that comparator will produce 1. If it is that input is a false condition, so this comparator will produce a 0 output here. Okay, so let's check. Now I apply the VA input to this first comparator and also I apply this VR by 8 to this inverting terminal. So basically I told you the highest value is getting from non-inverting means the comparator will produce 1, otherwise it will be produce 0 to the output, right? So next again I apply input signal, same process will be continued. This time the second comparator will also enable. After that again I input value applied, third one is enabled. So like that the total comparator will be enabled. Okay. So that's why we use one tabulation method for understanding that. That is applied input. So the applied input is VA, that will be written here as first one is 0 minus VR by 8. Okay. 0 minus VR by 8. So in this condition, we have totally 8 comparator, right? So I write it here as x0, x1, x2, x3, x4, x5, x6 and x7 as our comparator output, and output of this encoder is y0, y1 and y2. Okay. So in this condition, so this value is applied to this comparator 1, that is this comparator. So in this time the value of VR will be high, so the comparator will be enabled. So others are 0. Okay. So remaining comparators are in an off condition. After that we apply this signal is VR by 8 minus 2 VR by 8. That is our second signal. So in this condition, the first and second comparator will be turn on, remaining or goes to off condition. Okay. So in this stage, the first comparator output is the 1. So the output of encoder is 0, 0, 0, 0. So second one is about the x1 will be highest, going to high stage. In this stage output is 0, 0, 0, 1. So like that we have to write the same procedure too until this last comparator will be turned on. Okay. So same. That is 2 VR by 8 by minus 3 VR by 8. So in this condition, the third comparator also enabled. So remainings are 0. In this condition output is 0, 1, 0. Okay. So same condition will be applied. I have told you till this last comparator will be turned on, right? So at that time the output of the input of the comparator is 7 VR by 8 minus VR. In this stage all the comparator will be turned on and the output of the encoder is also 1, 1, 1. Three outputs are going to high condition. So this is what the flash type ADC will works. That is, it accepts the analog signal. After the processing by using the comparator, it will convert that signal into a digital formation. Thank you.